The topic really, again, is, as it relates to building information modeling, is how building information modeling, started kind of with the architects, has moved into construction, is now moving towards owners with downstream things, with facilities management. And one of the pieces that's becoming more and more, I guess, beneficial for people is pre-manufacturing, off-site manufacturing, basically moving a lot of the building information modeling processes and the eye and information are being able to be pushed out to actual fabricators. So what they're going to talk about tonight is pretty much the fabrication piece that goes on the MEP side, mechanical, electrical, and plumbing. And you guys will see some really neat stuff that's going on in the industry right now. So I've already spoke to the gentleman. We basically have Scott Hendrix, who is coming in from Las Vegas with our Skype. You'll see him in just a second. There he is. And then Lyle Yanda is also obviously here, and they've split up the presentation, so they're going to handle that. They've already told me to tell you that this will be a relaxed environment, that this is just a friendly kind of thing amongst all of us. So if you have questions, please speak up. Scott's field of view, he may not be able to see you if you raise your hand, so just speak up, all right? If you have a question, if you want to wait till the end, that's up to you too, but we'll have time for the end for questions, but otherwise we're going to let these guys get started. Does anybody have any questions right away?
So before we start, do we need to introduce ourselves?
Oh yes, thank you very much, please, thank you so much. Okay, so again, my name's Jeffrey McDonald. I'm an account manager with DC CAD. My background is in design, and I've been doing basically Autodesk design work for 25 years. And I love talking about BIM. I'm going to be in this industry one way or another probably till I'm old and gray, because I just find it very interesting. So let's just go this way. Go ahead, yourself, and then we'll work around the room. Just say who you are and what you do. And
I'm Andrew Pitcher. I'm a BIM specialist with Joris General Contractors. I do pretty much anything and everything from the general contractor side involving BIM.
My name is Gabriel Olmos. I'm with Lopez Salas Architects, and I'm a designer there and also their BIM specialist guy.
Hi, my name is Eric Maldonado, and I'm just really interested in BIM. Don't have much experience. Looking forward to learning something new today.
My name is Eduardo Nunez. I graduated from UTSA this Monday. So,
congratulations.
I'm Ray. I'm teaching BIM in UTSA for construction science and management program. And these two are my students.
So, one of the BIM students at UTSA as well. But I graduated in December. My name is Pedro Ibanez.
I'm Bernie Tomasi. I'm the president of TSI, Technical Sales International. We're an Autodesk ISV. We're a developer and value-added reseller. Up until 6 months ago, we were also selling this. These guys are our competitors at this point. But what we bring to the table is a lot more detail in the actual eye in BIM. More than just the geometry, we bring pricing, labor units, plus a complete configuration that will work for the MEP trades.
I'm Doug Weebrock. I'm president of DC CAD. I'm his competitor. I'm also a licensed architect. And Autodesk and I went to Europe in, I think, 2001. And that's where we saw BIM for the first time being used on some huge projects. And it really blew all of us away. And I've been excited about it ever since.
I'm Jonathan McCauley. I work for Ultraman Inc. And I've been an electrical designer using BIM for 13 years. Previous to that, I've had architectural experience and HVAC. And well, I'm on LinkedIn, so if any of y'all have any questions or want to contact me, just give me a shout.
I'm Bruce Sims, BIM designer for Ultraman Inc. as well. And we're here to find out how to push the limits. So that's.
And I'm Lyle Yanda. I'm a software specialist for DC CAD. Here to kind of show you what the fabrication software is all about from start to finish. It's a fully integrated program from bringing a Revit drawing, converting into CAD, taking it out of CAD, estimating in CAM for your prefab and for estimating. So, like Jeffrey said, if you got any questions while we show you all of this, feel free to ask, and Scott and myself will do the best to answer them. And then, Scott?
I'm Scott Hendrix, Solution Specialist at DC CAD, coming to you from Las Vegas.
Need to get you a really cool background photo there.
Yeah.
Maybe of the strip or something.
Okay.
Put the logo of DC CAD on one of the buildings, right?
There we go. So I think that takes care of all of our requirements, so we can officially get started. So the floor is y'all's. Scott and Lyle, take it away.
So the first thing I want to do, knowing pretty much everyone in here is probably using Revit, I'm assuming, is just kind of show that conversion. I've just brought in a Revit drawing. With the Revit Convert, when you download the Fabrication CAD MEP, it gives you this add-in that allows you to export an RIF file to open up into the Fabrication CAD MEP. Export it out. So I will now come into AutoCAD MEP. Now the Fabrication CAD MEP it's an Autodesk product, but it's still an add-on, so it sits on top of AutoCAD. I'll go ahead and bring this in. And as you can see now, I have brought it into CAD and I am ready. Brings it into the CAD MEP items. There's a fully integrated database through all the products. That first screen that you saw was some of the mapping. I kind of went through it quickly just to bring it in, not to get too detailed into it. But these items are stored in your database. Again, as you can see in one of the service templates. Brought it in fairly nice. As you can see, there's some breakups in here. Again, the import's only as good as your Revit drawing that is given to you.
I've already got questions. First of all, I find it amazing that you're going to AutoCAD because the industry is wanting to go to Revit.
Right.
A lot, probably half the industry does not want to. And so, yeah, I found that very interesting first. Do you have anything to say
Well,
about
with that, I mean, Revit
is that intentional to go to AutoCAD?
Well, this allows you to bring it in and start doing your prefabrication. What this program allowed, bringing it in.
Detailing? Or?
Detailing, oriented, because of course, Revit is design based, and so.
And that's a separately purchased program?
Yes.
So, not just in the fab, there's a middle program that you get, or you get that with the fab?
Well, now, see, that's a good point. In 2014, there was a product called Fabrication Fab, that was discontinued and rolled into CAD MEP. So now it's basically one product.
It's already
it's into the CAD MEP. So that's the add-in. So you have AutoCAD as AutoCAD MEP or AutoCAD, and then you have Fabrication CAD MEP. That's it, and that allows you to bring in, when you download that, that gives you that add-in tool in Revit. That allows you to export it out and bring it in.
Well, I want one.
Well, if I could interrupt, Revit at this point doesn't have the capability programmatically to do this. It's coming. So they export out of Revit into the AutoCAD environment because it's more mature and has more capability at this time.
What's your cycle time do you feel that would happen? I mean, because I see it like 4 or 5 years out where you really can start to do what you can with AutoCAD in Revit programmatically. Is that, I mean, do you feel that
4 or 5 may be a little bit long, but certainly more than a year.
Let me also interject here. We already have a product that'll draw in Revit with the intelligence that is shown right there. We call it Revit MEP SysQ. So we're already drawing with the intelligence of Revit, as opposed to having to do the conversion out of Revit and bringing it into AutoCAD.
Right. Well, the problems that we find is that Revit isn't very user-friendly. We have to have it because we're electricians.
Yeah.
Duck guys, you know how easy to have it. So we have to basically program our own items.
Yeah, you're creating your own family.
And that's where AutoCAD is the huge benefit, is we can do that not having, you know, an experience.
Well, at the end of the day, you really want to get into managed content.
Right.
And that's what we do, is we manage content, we create it, we update it, we manipulate it for you, so you're not having to create it at the end of the day. That's really where you want to be.
So just real quick, come in here and refill it. Find my source. As you can see now, it fixed some of the little things like this. Just go ahead and delete those 2 lines there. Bring this over and refill it. So you can see how from the process you kind of come in here and start manipulating it in CAD to get it ready. Now the next thing I want to show you is take this into CAM. Being that this is HVAC, the sheet metal, I'm going to go ahead and filter. And this is also, this is the fabrication cam duct part of it. And now I've brought in that job. I'm ready to, I've got a table already set up. I'm going to go ahead and nest it. I'm ready to manufacture. There's my sheet, there's my NC number. It's ready to go out at the table. Just show a little preview of what it would look like out at the table. So that whole process from the time I brought it in to Revit, into CAD, into CAM, I mean, really it's as quick as that to get to start the manufacturing part of it. Let's go there, and there's all those pieces to that. So that's kind of the process, and then this file I can take into estimating as well. And get pricing. And then there's, of course, you got to set up everything in the database. But again, just wanted to show that process from Revit into CAD, CAM, and Est. The next thing I wanted to show you is I'm going to stay here in Est, start a new job. I'm going to start that job in Est because basically, as the estimator, you're going to be estimating the job to get the quote out, and then from here I can send it over to CAD, and that's what Scott's waiting to do. Is he'll take that job and he can again cam it out for. And here I'm just bringing in a PDF underlay to draw on top of. Scale it. In all these products, there's a tool a drawing tool within it. It's called Design Line, and it's basically what's nice on the estimating side. You're not I can draw it to scale, to elevation, but as an estimator, you just want to get this out, get pricing to your stuff, and send it out. That's where it's nice. I can then send it to CAD, and where it's more detail oriented, and that's where they can worry about it. But I'll go ahead and. Transparency, see my design line. And as you can see, they're pretty much just an example of drawing it out pretty quick. Again, as you get used to it, it get a lot quicker, but filled in my hangers, just filled in all my joints and so forth. And I can go to my item tab here, and again, in my estimating summary, it gives me a material time, fab time, and install time. There's the total cost. So I'm ready, I've just give that quote out, and what I'll do is I'll go ahead and do a save as. I will save that. And then Scott, who's in Vegas, he can go ahead and open that job up, and I'll give you the floor, Scott.
Can everybody hear me?
Yes.
Yes.
Yep.
Okay. I wasn't sure if my mic was working or not.
We can't see you though.
There, is that better?
Yes, that's better.
Okay. All right, so our estimating department has finished the estimate on the project, and we've been awarded it. And so what I'm going to go over is the next steps that in the detailing department, things that we would do in there. First thing I started is I have a drawing here where I brought in the same background, minus the ductwork, and I'll bring in the estimate from the estimating. So now in CAD I have the ductwork that Lyle just drew and just finished in the estimating program. And then it's my job to do some detailing to it, make some adjustments, and take it into coordination. Through the coordination process, we're going to have to make some edits to this. For instance, if we say that we had a section over here where we had a collision, and we need to make an offset in this line to get it over here closer to the wall and out of somebody's way. So I can make those adjustments through the coordination process, by just manipulating my design line around, refilling until we're clash free, and release the fabrication. Once we're released the fabrication, then we can take this ductwork and, as Lyle showed you with the CAM product already, is that we can take this and send this to a plasma table, and they can cut all the pieces necessary to fabricate this ductwork. Now we can also start jobs right from in here in CAD. If I take and I'll isolate my background, and we'll take a look at some of the piping. I have some underground plumbing here to a couple restrooms, and a floor sink out in the mechanical room. So we'll switch to some waste service to get started. And the same tool that I used in the S program, we also use in CAD, and that's design line, where we'll come in and start putting our piping in. And in here we can even place our clean out fixtures, things like that as we go.
Hey Lyle, are you, on your GoToMeeting, are you set for telephone or web? If you'll switch to telephone, both of you, it'll stop that beeping.
Yeah, is it as loud on your side?
No, it's real loud. Driving me crazy. So if you'll just go into your GoToMeeting and switch it to telephone mode.
Where's that? Go.
Expand the panel out.
Yes.
Yeah, I think he's already done it.
Yep, it's already done. Okay.
Thank you.
No.
All right, I think that's Scott doing that, man.
I don't know.
When we get done with placing fixtures, I'll show you.
All we're doing this process pretty much trace over the engineer's drawing to give a start. But just by tracing over and giving it some elevations, you can see that I now have piping underneath that we can see in here. And all of it uses the actual manufacturer's the fittings with the manufacturer's dimensions on them, so that every piece in here is ready to fabricate. I can tell them exactly how long to cut this piece of pipe. And create fabrication drawings from this, material list, And any changes that I make during the coordination process, I can then push back over to Lyle in the estimating department to run an estimate on it. Fabrication drawings. For those of you who worked in CAD, I think they're awfully slick in here. We can take, we call them spools, create a spool, tell it what pieces that we want to prefabricate in our fabrication shop. And it will automatically generate that fabrication sheet for us, putting a bill of materials for this spool, so that they can take and prefabricate this in the shop, saving them time and money, having workers work in a better atmosphere, out of the weather, and can be much more productive in the fabrication shop and the building of this. So this will give them a sheet. That we'll send over to the fabrication shop to build. And after, then there are also tools in here for annotating these to build our shop drawings, to go out to the field. So these work a little bit different than standard AutoCAD annotations that we place the annotations on here. They're attached to the items themselves. If the items moved or changed in any way, then these are dynamic and will change with them. So that would allow us to create our shop drawing sheets. And one of the last steps would be to, well, we've got a couple more. We can also run reports on this. There's a lot of information contained in each of these items that we can run reports on, say for bill of materials, cut lists. So if we run a report on this stuff, we can also run multiple reports at the same time. I have 3 selected here: bill of materials, a hanger cut list, and a piping cut list. So we go to that. Here's my bill of materials to send to purchasing. Purchase the necessary items to build this building. I have a hanger cut list here with all the hangers, what size rod, so that hangers can be prefabricated and sent out to the field. And a cut list for all that piping. Like I said, we were going to prefabricate this in the shop, but the first step would be sending this pipe list over to a table where someone can sit and cut up all this piping and label it. It also has the ability to print out labels to stick on each of these, so we knew what each piece of this pipe was for. And once our hangers are prefabricated in the shop, next we can have we can send out a file that would go to a total station, which is a robot-guided laser system for pinpointing the locations of the hangars in our actual building. So here we have the file for the trembled total station, and we can see our piping inside of here. And the top of each of these hangers is a point. This file, we can then tell it where we want to start laying out our tremble. We're going to start here, and it will guide through all those points, finding the shortest point or the shortest path through all those points to lay them out. And then once we hit OK, it would create the file that we would then import into the handheld computer that operates the trembled total station. So in the field, with the total station, we'll then have the handheld. You'll have basically almost what you see on the screen here. You'll have a background with the points, and when he selects a point, then the robot will spin around and point a laser at the location where this insert for this hanger or needs to be placed on the structure. And again, once everything is done and we're through coordination, we made a lot of changes, rerouted a lot of piping. If we then want to run an estimate on what our job is now that we've made all those changes through coordination, we can simply export this out to a file and put it back in our job folder that they can open up inside of the S program to now get the cost on, or actual cost of building the building once. All right, did I miss anything, Lyle?
No, I think you are good on.
Lyle and I are kind of rookie presenters. This is number 2 for us, so bear with us. But if it seems a little stiff to me too. Any questions?
You guys have any questions at all?
Can you change those hangers?
Yes, absolutely. We have different types of hangers in here that we can then just put into our service so that it fills with whatever type of hanger we need. We have built different types of hangers for different types of pipe, different sizes. Lots of adjustment on it.
Now, are you having to redraw it for each program, the CADD, the MEP, and is that what's going on?
Well, no.
No, we do not. If we are given a Revit model, then we can take that, like Lyle showed me, and convert it, and that will give us our start. Jobs will come in differently. Not all jobs are given the mechanical contractors Revit drawings that they can do that with. If they didn't have it, then they can do exactly what I did by just going over either a PDF background or a DWG background from AutoCAD. So you can kind of do it depending on what the job situation is.
Like I stated before, with the fully integrated program, as you can see, Scott's in Las Vegas, and we're working on the same database. And as soon as I make a change or say something, he's able to bring it in, so you don't have to redraw. I was able to send him the duct, and so now he can draw his pipe, or vice versa.
When and how do you guys do the clash detection? With the other stuff, like structural elements. I mean, if this is just a 2D drawing right here, and
right? Well,
you're able to reroute the ductwork. How do you know if something's there or not in this 2D drawing?
Well, there's automatic clash detection in here that you can turn on or take it into Navis. That's typically.
Well, this is all done after coordination is finished. Correct. So, I mean, you're doing here and you come out with your bill of materials and your prefabricated products. You've already done clash detection. You've already done
right, but during this whole process, it's going back and forth.
Yeah, I think the contractor's going to do a high level of clash detection on their own through the coordination meetings that are going on, and then typically, from what I understand, the fabrication people are going to get involved and they're going to value engineer the job, and through that process there's going to be further potential changes which leads to more verification and coordination checking. So this program has embedded in it its own clash detection for the elements that's inside of it. In other words, clashing with ducts, clashing with piping. But if you were going to take it to something architectural, you would need to take it out to Navis and vet it against the balance of the model. So ideally in this scenario, I think what you're talking about is that the fabrication team would have access to the most advanced Navis model that was out there and had been clash detected and resolved at that point, and then they would be back checking it on their design as they went, ideally. I think that's the way that would work. Does that sound right to you, Scott?
Yeah, there is some clash detection built into the program already. So generally, and I worked in a detail department, and one of the first things I would do is run a clash detection within here to see clashes that I may have created myself. But ultimately, the fine tuning and is all done in Navisworks.
Now, are you talking about the clash detective that's in AutoCAD? That comes with AutoCAD?
That comes with CAD MEP.
Okay.
Are they the same model or Revit families from Revit in this program? Or these components over here? I'm not sure if I'm making sense. How close of size and dimensioning of the ducts and pipes are they from Revit? Or are these out of the box components that you guys tailor to manufacture specs and all of that?
These are exact manufacturer specs. We didn't bring the parts over from Revit. What the Revit Convert process basically did was to take our design line and run it through the existing Revit parts, and then bring that design line in that then we can fill with actual manufactured parts.
So I would say in general,
Well,
the way I would answer your question is the Revit is a lot less accurate.
Okay. But that's what I'm saying. Like, if I put I don't know, 8-inch. I mean, I'm not a big MEP guy. Just thinking from outside looking in. If I put an 8-inch pipe in there, but it's not going to squeeze in through something, how accurate is it? Am I making sense?
Yeah, I would think that that it's going to have to go through these guys no matter what. You know what I'm saying? The Revit, in general, the Revit families are not built as accurately as what this stuff is. This stuff is fabrication ready, and it is the tolerances are much higher.
But it's more detailed at this level. When you're in Revit, you're going to probably have the same outside diameter for when you're building an architectural model, so you can comfortable that you're going to fit in that space, in the wall cavity or whatever. But when it goes out to the contractor, he's going to want to know more detail at that point to get this installed.
I mean, as you saw from when I first brought it in, there's some pieces missing. And that's kind of, like I said, depending on the conversion's only as good as your Revit drawing starts with. So sometimes I may put, for instance, the wrong bend or something in there that wouldn't work in the real world. Well, that'll here bring it in, get it to exactly what it would be in that building, and send it out to you.
So it takes that design line from Revit and then applies whatever fittings and connections that you have in AutoCAD to the design line the same way that it does in Revit whenever you're actually drawing it, and it's looking at your your preferred fittings, I guess.
Exactly. So like those items you see over there on the left, that's a service, and so you're saying that service is basically, you're telling it, like on here, it's a sanitary waste. So when I bring over that Revit conversion, export out the sanitary waste, you just, and bring it in here, and it'll fill it with those items that you set up to fill properly.
Yeah, so it's, whenever you see this joint, use this particular
exactly
thing.
And if, Scott, maybe if you want to show the annotation on the design line, and it kind of shows you how it's in the language there. So it's asking for, the language within the program that the fittings follow.
But when you're using custom families, how are you going to translate those fittings from one to another? If
you create a cross-reference or something?
You have to create a cross-reference list almost every time you do a job.
It takes sizing and routing. So the design line is pretty much just sizing and routing. So it'll take your sizing and routing from Revit and pretty much just create this line right here. Now when Lyle brought it over, it looked like it came over with parts, because what it did was it hit this fill button in the process of bringing it over. But really all we needed out of that was routing and location, or routing and sizing, I'm sorry.
Yeah, so you're saying it's a 2-inch, and then you just have your, whatever you're going to call it, 2-inch in your table that here's where I'm going, I need a 2-inch there, and it populates that way.
So instead of using the Revit items, we are filling them with the items that you see here on my screen.
Gotcha.
So the database we are looking at, like the fittings, the database, and or the library we are looking at. Is this like created by your company or from the manufacturer or from the software? So where is this database come from?
Well, when you buy the product, Autodesk has a standard library that they've provided.
So they provide
with standard services, and and then from there you can customize it how you need it, because of course, I mean, there's still every shop is different, and you're going to need it set up how you want it at your place.
And that is a big difference. If you go into Revit, you won't see any manufacturer names on any of the Revit things. Like if you look at a 2x4 lay-in light, or if you look at a wall, you're not going to find a Leviton receptacle. You're going to find a duplex receptacle, right? So in Revit, it's very, very generic. It's not manufacturer specific, and it doesn't need to be because it's for design intent, right? But at this level, it is manufacturer specific, because you're at that higher level of detail, and there are variances between one manufacturer's product line and another. So this is what's interesting about this to me is that this is, building information modeling is very, in the architectural world, is very again, you'll see the architect will stand back and say it's just for design intent, and you do clash detection and everything else. But this is as real as it gets from a 3D model. It's the fabrication level of detail is much more intense, and I just find it very interesting because it is much more closer to real life.
And this CAD, people put all the manufacturers' product line there, or they just promote like some of them?
Right. I mean, there's some default manufacturers. It's not going to be all of them,
okay.
Of course, depending on what you're using.
But
it'll have a standard in there.
Okay. If you choose to use other manufacturers, you can still download libraries from their web or something.
You can build your items.
Okay. So you build them.
Yeah, it's a little bit of difference. What we value add with our product is we're up to almost 1 million items that are already manufacturer specific that we bring out that are both working with this product as well as Revit families. So we've taken the time to get all those manufacturers and go to their websites and get all the dimensional value, be able to populate a database, as opposed to what you get out of the box with Autodesk, and then you'd have to go back in and create all those items. Okay, and in addition to just the geometry, there's also pricing that's attached to it, and standard labor get rates are attached to it, and then linked right back to the PDF file from the manufacturer, so you can look and see, hey, this came from this manufacturer on this page. So it's true BIM at that point, all the way through to the facilities management people.
How many of you guys in the room have used the trembled stations or have been on jobs where they've used them? Don't you guys have some of those? I think?
Yeah, we have a few.
And you have, how helpful is that? Is that a huge time saver?
We use it for inserts. It cuts. It helps with just getting our racks up so fast, and safety. From a safety standpoint, you're not on a ladder or lift as long, and drilling. Using drill bits constantly and
underground.
That's the whole thing about Trimble is a safety issue too. If you're prefabbing your hangars and you get them out to the field, you don't have people up on hangars and you're not drilling, and it's a huge safety issue if you're using it. We sell the Trimble units, and we found that when you get to 5,000 points that you've laid out in the field, you've basically paid for the unit at that point, and then you're saving labor. It's about a 70 to 75% savings of layout time in the field.
We bought one specifically for one job because we had 2,000 points per floor, and we had 14 floors.
Wow, they work. They work.
Yeah, one got knocked off the building.
So I guess something that I want to point out to the folks in the room, especially the students and stuff, is that what's driving a lot of this stuff is obviously in this case. A lot of times it's design and cool pictures and stuff like that. In this case, it's pure money, right? There are things that we've talked about today. The Trimble station saving money. One of the things we've heard from clients that work in this realm is that their insurance they have to carry drops dramatically when they can prove to the insurance carrier that they're doing 50% more of the work off-site and doing their fabrication off-site as opposed to fabricating on the job. Their job site insurance protecting their employees drop dramatically. So there's all kinds of ancillary cost savings that are going on business-wise that are driving this industry. And in the end, it results in a better product for the owner. Because you can imagine the owner now has much more of if this information is pushed into the federated model at the end, that's awesome, right? You have a real live, true as-built. A real as-built, right? Where you can go in and select and see the manufacturer part name.
Well, speaking of, what does this export to? A Revit file? Does it go back into a Revit file and bring those specific parts back into it?
Is it an IFC or is it a DWG that you'd put back into the model?
It's not there yet, right? You're talking about round tripping, okay?
Right.
So
go back and have the actual.
Yeah. So the concept is that you would start with the consulting engineer has a Revit model that they use to do the basic design work. That gets approved and that gets passed over to the fab team through contractor, subcontractor, fabrication people. Okay, so it goes down there. These guys finish the work, it all gets installed, somebody walks around and says, yes, that's the way it was installed. I have seen videos where they take the information and it pushes back up to Revit and it reconverts it into Revit files. But from my understanding, from what I understand, on the back side, on the Revit side, it's incomplete and it's not. It can be done and it will be done in the future, but they're not there yet.
You just want a federated model.
But also AutoCAD.
Yeah. You're just looking for a federated model, so you can take this as a DWG and put it in a Navis model world, and it'll be fine.
Right.
Well, is this export to an NWC, or does it only go to IFC or DWG? That's a good question.
Well, this is on top of AutoCAD, so it should be native DWG,
all
right?
Those file types are supported. It can go full. You can take this and you can open it back into Revit, but again, it's there for visual representation. Yeah. It's not going to have all that information in it, and same with the Navis. It's in there. So yeah, you can open this file, and again, it's just a DWG.
So if I just want to NWC out and open it in Navisworks, how much information comes with that file?
A lot.
Well,
and then you don't even really. There's a free enabler. You could open up the DWG. You can do the NWC out, but you can. Autodesk has an enabler that allows you to open up this in Navis. And like Scott said, it brings over a lot of that information.
Yeah, once I bring it into Navis, I can get down to the detail where I can isolate in Navis by material, tell it, and select just everything that's made of copper. That's the kind of level that we have inside of Navis.
Can you add attributes, if you will, so you can tag it with more information that you want to have?
Yes. As much as you really want in there. There's areas for custom data that you can also tag it with your own custom data.
So these aren't really. Are these more of an MV part, or the Just they're more than a block, right? These components.
Yes. Yeah, much more than an AutoCAD block.
Well, they would be an MV part because a standard block, they have connections attached to them that can be pulled, push-pulled.
Because that's where we'd like to leverage the property set data or something like that.
Right.
And now you can tag this with elevations as well, easy enough, right? This is.
Yep. Yeah, it knows what elevation it's at, and we can just tag it with its elevation.
And how does this handle?
I trip over that one.
How does this handle a unistrut rack with multiple diameter pipes on it? Does it output bottom of pipe to the strut?
What was that again?
Unistrut. If you did a unistrut rack and you have multiple pipes, to say you have 3 2-inches, now you want to add a 3/4, is it going to drop them down to the bottom?
No, that portion of it is kind of manual. I usually rotate my model so I can see down that rack, and I'll lower that design line, whatever it takes to get them to set on it.
Okay.
There also is a multi-service design line in here, and we didn't show that, but where we could draw an entire rack all at once, having multiple pipes on it. And that is fairly new inside of here, like the Revit Convert that was in another product that they brought into here. But you could draw that entire rack all at once.
And that's a 2014 thing, isn't it, Scott? Isn't that
Yes.
brand new? Yeah, it's a brand new feature this year.
Okay.
Does anybody have any other questions?
The Trimble, whenever you're trying to export the Trimble points, what is it using in each part as a base point?
It'll be the same as your model.
So it's using the base point,
Not only
the block base
file, but the backgrounds go with it. So the Tremble will take in 2 files. Background, depending on which handheld you have, they're different. Whether you have a touchscreen based or the Nomad that's based on Windows CE. So, but they'll take in both and overlay on top of each other, so that you have more than just points. You can actually see where it goes in the building.
So you'll need to set this up on some sort of real-world project base point in order to take that into the field.
You need 2 control points basically.
Yeah.
Put into that drawing. The first thing you do is he knows you go out, you set the robot, you shoot point A and point B. The more points you have, it works a little bit better. But once you have those control points, it'll know where the array of all your hangers, sleeves, inserts, pads, and all that out there on the job site.
What I'm asking is, I need to put a point on that hanger so I can put an insert, an embed in there.
Okay.
And the Trimble point, the Trimble is going, the Nomad is going to need a point in space relative to 2 control points to be able to place, to tell the operator to place that insert.
Yes.
There in the pan or whatever.
So you're asking if it's at center of the
So that's what I'm wondering. Is there
Scott,
I know Trimble can automatically populate points based on the base point of blocks. So that's what I'm wondering if y'all take that into account, that hanger right there has a base point, an inserted base point at the top of the rod, center of the rod.
Yeah, Scott, if you
do it as a point at the top of the rod.
If you do a trim V, you can view that file and it'll show, yeah, there's a point. That's what he exported out when he selected the whole drawing.
Yeah, little green X.
That little green X, that's the control point.
Oh, okay.
There they are.
Okay, yeah.
And then if you go find that, it'll give you, as you can see, all the coordinates to where that point is at.
So now I know this is a different type of view. For instance, if you have concrete beams for your structure, and one of these is going into the structure, is that rod going to automatically? How do you get that rod to automatically change its height?
Yeah, we'll set that up in advance. We call them sections in here, so we set up the section and tell it where we are attaching to the structure, and they will automatically go to the proper elevation.
Okay, and then in your cut sheet, you'll get the proper rod length.
You set it up individually per rod, or does it automatically?
It automatically
We set it up by section of the building. So if this section of the building, the attachment to the structure is 16 foot 4 inches, then we tell it that these hangers are in this area, and then they will automatically go to the proper elevation.
Well, for a pan deck, you're going to have fluctuations every 5 feet, say.
Yep. Generally, what we did with that was we go to the top flute of the pan deck, and the guys in the field would cut off any rods that landed on the bottom. So that way we could still fabricate them in the shop, but then didn't have to, because there's no way to know where those highs and lows of the pan deck are going to be in the actual building.
Interesting. If they differ from the plan.
Yeah, so it's pretty simple for them to cut off 3 inches on every one that fits on the lower flutes of the pan.
Well, we're seeing, I mean, a pan deck is, the ones we have are 2 feet.
Yeah,
So cutting 2 feet off of a rod, potentially every other rod, is kind of wasteful.
That's kind of a lot of waste.
Anyway, good.
2 feet?
Right.
24 inch, yeah.
We have a
beams.
25 inch deep beams with joists, and every time you go into a pan, you're going to rise 24 inches, or well, I guess 20 inches.
Yeah, if I have that big of a discrepancy, then I may attack it a little bit differently.
Okay.
Basically, maybe something you have to look for in your Navis model.
Yeah, we would.
But that
We would manually. That's
Okay,
what we're
so
asking if there's an automatic.
But manually, we can touch a rod and actually change its height.
Yeah, exactly. You can come in here and edit those points as needed.
And just say, okay, yeah, we got this one that's going to be that high.
Actually, we do have that in our Revit system where it'll go in and it'll look at the underside of your deck, even if the deck is sloping like on a parking garage,
right?
And it'll automatically adjust for how far you're taking that up or down. So when you have a deep blow-off pan like you're talking about, it would actually take it to the inside of the deck if the deck is, a 3D model, and get the correct length of your all-thread rods. And again, you're going to put an allowance in there for how long you want to take it up into the concrete.
Yeah, it's got to go into
whether you
the
got to bang it or whatever you're putting in there as well.
Right.